Welcome to Mathematics Track. This is Saritha. Today we are going to discuss a topic of polygons. So what is a polygon first? Polygon is nothing but a simple closed plane figure formed by line segments. Or you can define the polygon in another way also, that is a simple closed plane figure formed by at least three line segments. For example, a triangle is a polygon, isn't it? Because the triangle is formed by a three line segments and it is also simple closed plane figure, isn't it? And quadrilateral, yes, it is formed by four line segments. And similarly, if you can have five line segments, then there is a chance of forming a pentagon. Depending upon any number of sides, the polygon may be any type of polygon. It may be triangle, it may be quadrilateral, it may be pentagon. So all you need to have is it must be a simple closed plane figure formed by line segment. So in this definition, the line segments indicates the sides of a polygon. Okay. So these are the definition of a polygon. So for example, we know triangle, it is made up of three line segment. We know quadrilateral, it is made up of four line segment. And this is a pentagon. A, B, C, D, E, pentagon. And it is made up of five line segments. See, 1, 2, 3, 4, 5. Five line segment. And it is simple closed plane figure. Yes. So this we call as a polygon. So similar to quadrilaterals. In the quadrilaterals, we have seen that convex quadrilateral and concave quadrilateral. So similar to quadrilaterals, here also in the polygons, we have two types of polygons. What are those? Convex polygons and concave polygons. What are convex polygons? See, in this polygon, if you consider all internal angles, how are they looking? So they are looking like all interior angles are less than 180 degrees, isn't it? So this angle is less than 180 degrees. This angle is less than 180 degrees. Yes. So all internal angles are less than 180 degrees. That is why we call this polygon as a convex polygon. Okay. So then what is concave polygon? Concave polygon is nothing but if at least one of the interior angle is greater than 180 degrees, then we call that polygon as a concave polygon. See, okay, this is a polygon, isn't it? Yes, it is a simple closed plane figure formed by line segments. Yes, it is a polygon. But you look at these two angles. These two angles are greater than 180 degrees, isn't it? This angle is greater than 180 degrees. This angle is also greater than 180 degrees. So if at least one of the interior angle is greater than 180 degrees, then we call this polygon as a concave polygon. Okay. These are different names of a polygon according to the number of sides. See, if we have three number of sides, then we call this polygon as a triangle. See, look at the figure. And see, if we have four number of sides, then we call that polygon as a quadrilateral. Yes, this is a quadrilateral. If we have five number of sides, then we call that polygon as a pentagon. See, look at this 5, 1, 2, 3, 4, 5. 5 number of sides are there. If we have 6 number of sides, then we call that polygon as a hexagon. See, this is a hexagon. Yes. If we have 7 number of sides, then we can either call it as a heptagon or you can call it as a septagon. You can call either ways. Yes. Either it may be heptagon or septagon. So this is the heptagon. Okay. And if we have 8 number of sides, then we call that polygon as a octagon. Yes, this is a octagon. And see, if we have 9 number of sides, then we call that polygon as a nonagon, which is looks like this. Yes, and if we have 10 number of sides, then we call that polygon as a decagon. See, it looks like this. Yes, if we keep on increasing the number of sides, we name according to the number of sides. Okay, we have one formula, that is the sum of all interior angles of a polygon of n sides. See, if a polygon has n sides, then what is the sum of the all interior angles of this n-sided polygon? If there are n sides, and the sum of interior angles which is equal to n minus 2 times of 180. Yes, either you can write this as a 2n minus 4 times of 90 degrees. Okay, so this is what sum of all interior angles of a polygon. See, if you take a polygon, so this is a pentagon I am considering. See, this pentagon has 5 angles. Yes, this is A, B, C, D, E. So these are angles A, B, C, D, E angles. So if you take the sum of all the interior angles of a polygon, which is nothing but angle A plus angle B plus angle C plus angle D plus angle E, which is always equal to, here as this polygon has 5 number of sides, in place of n, what you have to substitute? 5, isn't it? Which is nothing but 5 minus 2 times of 180. Okay, which is equal to 3 into 180. Yes, which is 540. This is how you can find out the sum of all interior angles of a polygon, any type of polygon. If there are n sides, here the formula is n minus 2 times of 180. Either you can write like this also, 2n minus 4 times of 90 degrees. Okay. One more property, that the sum of all exterior angles of a polygon is always equal to 360 degrees. The sum of all exterior angles of a polygon is always equal to 360 degrees. See, this is a hexagon I am considering. Okay, this is a hexagon. So we know at every vertex there is a chance of having exterior angle, isn't it? If you extend this side, then here the angle forms, this we call it as a exterior angle, and this angle we call it as interior angle, isn't it? So at each vertex, there is a chance of forming an exterior angle, isn't it? Yes, this is one exterior angle, and this is one exterior angle. This is one exterior angle, isn't it? So the sum of all these exterior angles, let us consider E1, E2, E3, E4, E5, E6. The sum of all exterior angle, which is nothing but E1 plus E2 plus E3 plus E4 plus E5. The sum of all exterior angles of a polygon, which is always equal to 360 degrees. Here we have considered hexagon. If you consider pentagon also, the sum of all exterior angles is always equal to 360 degrees only. So whatever may be the type of polygon it is, the sum of all exterior angles is always equal to 360 degrees. And another property, see, at each vertex we have interior angle and exterior angle. So these both interior and exterior angle at each vertex are always supplementary. Yes, so they are always supplementary to each other, which is nothing but the interior angle and exterior angles sum is always equal to 180 degrees. This is one more property of polygons. Okay. In the polygons, there are two types of polygons. What are those? Apart from concave convex types, we have one more type, that is regular polygons, irregular polygons. What do you mean by regular polygons? See, in a polygon in which all the sides are equal and all the angles are equal, then we call that polygon as a regular polygon. Okay. See, this is a pentagon. Okay. In this polygon, this all sides, this is a ABCDE pentagon. In this, all the sides are equal. Yes. And all the angles are also equal. Then we call this polygon as a regular polygon. Yes, regular means all the sides are equal, all the angles are equal. Yes, see, this is also a pentagon. See, 1, 2, 3, 4, 5. 5 sides are there. In this polygon, 5 sides are there. See, look at the angles. The angles are not equal. See, this angle is greater, this angle is smaller. So, like that. That is why we call this polygon as a irregular polygon. This is a regular polygon. This is a irregular polygon. Okay. Then we have seen that sum of all interior angles is always equal to n minus 2 times of 180. When you come to regular polygon, we can also find out each angle also, because as all angles are equal, we know sum of all angles, then we can find out each angle, isn't it? See, it has 5 number of angles, isn't it? So we know the sum of all interior angles is equal to n minus 2 times of 180 degrees, as it has n number of sides. This polygon has 5 number of sides. But if you consider n-sided polygon, there you will get n sides, right? So if you want to know each angle of a polygon, you have to divide with n number of sides. Then we can find out each interior angle of a regular polygon. Okay, this is not possible in case of irregular polygon, isn't it? Because in the irregular polygon, we don't know what are the angles. But in the regular polygon, we know that all angles are equal. If you know the sum, you can find out each interior angle, isn't it? So this is what that n minus 2 times of 180 is sum of all angles, and we have n number of angles, isn't it? That is why it is divided by n. We can find out each interior angle. You can find out each exterior angle of a regular polygon. See, we know sum of all exterior angles is always equal to 360 degrees. If we know in a regular polygon, if there are n angles, n-sided polygon, so obviously there are n angles. Yes, we can find out each exterior angle also. If you divide with 360 by n, then you can find out each exterior angle. So this is each exterior angle of a regular polygon, and this is each interior angle of a regular polygon. And these two are applicable only for regular polygons. Okay. Next, we will define a diagonal of a polygon. See, in case of quadrilateral, we have seen what is a diagonal in case of quadrilateral. If you join the two opposite vertices, we call it as a diagonal. But when you take more number of sides, see, if you take 5 number of sides, this is a polygon. See, how can we draw diagonal for this polygon? Means how can we define a diagonal in case of a polygon if more number of sides are there? See, this is a polygon and this is a vertex A. These are adjacent vertices of A. B, C, D, E. Okay. This B and E vertices are adjacent vertices of a vertex A. Isn't it? So, other than the adjacent vertices, if you join any other vertex in the polygon, then we call that line as a diagonal. See, if you other than these two adjacent vertices, yes, you leave these two vertices, you join these two. Yes, this we call it as a diagonal of a polygon. Yes, what about this? If you join this also, yes, this is one more diagonal of a polygon. So this is how we can define a diagonal of a polygon. Then how many number of diagonals are possible in case of a polygon? See, how many vertices are there in this pentagon? Okay, 5 number of vertices are there. So 5. Among these 5 vertices, you are leaving the two adjacent vertices. Okay, and you are leaving this vertex itself, means whichever the vertex you are considering, that is also we are leaving. So other than these three, and you are joining remaining all vertices. Yes, you are joining the remaining all vertices. So that is why we have to subtract 3 number, means 1, 2, 3. So 3 vertices we are leaving. That is why you have to subtract 3. So how many you got? 2. Similarly, in hexagon there are 6 vertices are there. Okay, in the 6, among 6 vertices, you are leaving 3 vertices because the vertex we are considering and the 2 adjacent vertices we are considering. So those 3 you have to subtract. Yes, 3. And how many? 3 number of diagonals you can draw. And this is only from one vertex you are considering. See, if you consider this vertex, what happens? You leave these two, A and D, and you can join this one and this one, isn't it? So, you are just leaving these three, means the number of diagonals you can draw in a polygon from each vertex. From each vertex, you can draw n minus 3 diagonals. Okay. And how many total number of diagonals you can draw? Which is nothing but n into n minus 3 by 2. Okay. So the total number of diagonals of n-sided polygon we can find out like this, which is n into n minus 3 by 2. Okay. If he asks how many number of diagonals can be drawn from each vertex, then you simply need to find out n minus 3. Isn't it? So this is from each vertex and this is the total number of diagonals. Okay, this is the total number of diagonals. And this is the number of diagonals from each vertex. From each vertex. Okay. This is what about a polygon. Thank you.